Hello guys, so today we're doing section 2.2. This is page 459, real numbers exponents. Alright, so let's go ahead and get started with this first example here. Our goal here is to solve for x. So we need to figure out what that x is going to be. Alright, so here is how we have to do this problem. The way we do it is we have to identify what the base is going to be. And what I mean by that is we need to rewrite 8 and we need to rewrite this in such a way that it has the same base. Let me actually do the problem and then hopefully you understand what I mean by that. So this 8, I'm going to rewrite it using base 2. Okay, the reason why I picked 2 is because I know that I could rewrite this one using base 2 as well. Okay, well 2 to the third will be 8. So it's 2 to the third, and then the x goes right there. You guys see that? And then 1 over 4, I'm going to rewrite it as 2 to the second. Now if I rewrite this 2 to the second using negative exponents, this is what I'm gonna get. So the reason why you want to have the same base, okay, is because now when you look at this, you can easily tell that, hey, this better equal this right here. So from this, I can say, well, 3x better equal negative 2. And then I solve for x, and my final answer will be negative 2 over 3 when I divide by 3. Okay? So in this type of problems, we want to rewrite them in such a way that I have the same base. Let's do this one here. First of all, identify what you have. You have a 5 right there, and you have a 25. So it makes sense that the base will be 5. And I want to rewrite that 25 in terms of 5. So we have 4 minus t, okay? Then 25, I can write it as 5 to the second. Then I have to multiply this t minus 1 as well. So notice, now that I rewrote this, I can see clearly that this is going to equal this right here, because we have the same base. And that's why you want to rewrite it in such a way that you have the same base. So in here, all we're solving for now is the following. 4 minus t is equal to 2 times t minus 1. Okay? Now let's go ahead and distribute that 2, so we get 2t minus 2. Let me add t on both sides. That's going to give me 3t, and let me add 2 on both sides. That's going to give me 6 on this side. That means when I divide by 3, I get 2 as my final answer. All right, let's go ahead and do another one. Okay, example number 3 here. Our goal is to solve for x. So we want to figure out what that is going to be. Well, first of all, let's rewrite this in such a way that first of all, I have the same base. So that 3, that 32, okay, since I have a 2 right there, I want to have the same base. So I'm going to write it in terms of 2. So 2 to the what is going to be 32? Well, 2 to the 5th power. Now, we already know how to write this in exponential form. We will have to write it like this: 2 to the 5 over 3. Since we have the same base, you can clearly see that x is going to equal 5 over 3. So x in this case is 5 over 3. Now let's go ahead and do number 4. If I have a 9 and I have a 27, what will be the base in this one? If you answered 3, you were correct. We need to write that 9 with base 3. So it's going to be 3 to the 2nd is going to give us that 9. Then I have to multiply that 2 times x minus 3. And then I have 3 to the 3rd is going to be 27. So as you can see, this must equal this right here because we have the same base. So I'm going to say 2x minus 3 is going to equal to 3. Let's go ahead and distribute, and we get 2x. Then let's distribute once again, and then we get negative 6 actually is equal to 3. Let's go ahead and add 6 on both sides. And we get 2x is equal to 9. Finally, we divide by 2 and we get 9 over 2. Go ahead and take a look at that problem right there. Make sure you're writing this down in your notes. Alright, let's go ahead and do number 5. Once again, we want to have the same base. Okay, there is 2 ways you can do this problem. First of all, we have 4 and 64. You have to realize that 4 to the 3rd, okay, is 64. So my base could just be 4. Okay, so I could keep that one just like that. There's some people that will choose to use 2, and that would also work. But I'm going to use 4 to not do much work here. So 4 to the 3rd power, and then I have that x right there, is equal to 64. Now you can see that this and this are equal to each other. We have x minus 2 is equal to 3x. Let's go ahead and subtract x on both sides. Such a way we get negative 2 is equal to 2x. Divide by 2 on both sides and you will see that you get negative 1 as your answer. Okay? All right. Now we're going to be simplifying radical exponents. Radical exponents. All right, so let's take a look at this one here. Because we have the same base here, you have a 6 there and a 6 there. Well, what I can do is I could rewrite this as 6, and then we are going to subtract now. We have square root of 2 minus, well, minus negative square root of 2. So what's going to happen there is that's actually going to become positive. Okay? And then we are going to get 6 square root of 2 plus the square root of 2. That's just simply going to be 2 square root of 2. Alright, now what I could do is, well, first of all, 6 to the second power is 36, but then the other one is just gonna lay in there like that, just outside. So that would be my final answer to that one there. Let's go ahead and do number 7. I always need to have the same base. Okay, we cannot add this plus this at this point, but if I have the same base, then I will be able to add them. So this 4 I could rewrite as 2 to the second 2 to the second pi times, and then we have the same base 2 there, 3 minus 2 pi. Since we have the same base, guys, since we have the same base, this allows us to add this one plus this one there. So I'm going to get it's going to be 2 pi plus 3 minus 2 pi. Okay? This one is very interesting because what happens is that this and this simply cancel out because they're opposite to each other. So you end up with 2 to the third. So you finally get 8 as your final answer. Let's go ahead and do another example, or actually a couple more. Okay, when you have the same base, for example, on this one, we already have the same base. Because we have the same base, this allows us to add this one plus this one there. So we have the same base, and we're going to add the exponents. Something interesting happens on this one. This and this cancels. And then we have 4 plus 1 will give us 5. And then we know that 2 to the 5th power, well, that better be 32. Alright, let's go ahead and do example number 9. Whenever you have an exponent like that, what you have to do is multiply this times that there. So here's what happens. So we have 2 square root of 3 times, so 2 square root of 3 times the square root of 3. Well, the square root of 3 times the square root of 3 is simply going to be 3. Okay, this and this will simply give you that 3 right there. You know, 2 times 3 is 6. So now we have 5 to the 6. So I'm not sure what that is, so I'm going to use my calculator for that right there. We have 5 to the 6. It's a huge number. If I wanted to, I could write the answer like this, but I do want to give you the big answer, which is this right here. Alright, let's do another example, making sure that we understand this clearly. Alright, in this one here, we are dividing. So one of the cool things about division is that if we have the same base, what we can do is subtract the exponents. It's kind of like this. There is a rule, if you have division and then you have the same base, and then let's just say that this is A and this is C, then B is equal to, or this will be equal to A, so that A minus that C. Okay, so that is the same rule that we are applying in here. So first of all, we have the same base. We have to make sure that we have the same base. Now we're going to subtract the top, which is 2 plus the square root of 7 minus what's on the bottom, this right here. Now we do have to use parentheses because we're subtracting the whole thing. So now I have, I'm going to distribute that negative right there. So that becomes -2. And this becomes positive square root of 7. Okay, in this round, what happens is that this and this cancels out. But then we do add this plus this right here, and we get 2 square root of 7. Now we are not done here. What I can do now is, well, 3 squared, what would that be? That would be 9 square root of 7. And that would be the answer that I'm looking for. So 3 to the second will give us 9 right there. Alright, so those are 3 more examples that you can use as a reference when you are doing the homework. Let's go ahead and do a couple more and then we'll be done. Let's take a look at this problem right here. It looks pretty difficult, but all we have to do is figure out what the base is going to be, and then we have to solve for x. Okay, so let's take a look at this. Since I have a 2 right there, I see that the best base for this one will be 2. So I'm going to rewrite that 4 in terms of 2. So 2 to the second. Now we do have a 2x right there that I'm going to put right there. Is equal to this half. What I can do is I could write it as I could use negative exponents. So that would be 2 to the -1 times 1 minus 2x, which is this right here. Now as you can see, we now have the same base. Okay, so 2 times 2 here will give us 4x, and then I'm going to distribute that -1, and I'm going to get -1 plus 2x. As you can see, because we have the same base, this right here will equal this right here. So now let's go ahead and write that down. We have 4x will need to equal -1 plus 2x. Okay, in this problem, I could subtract 2x on both sides. That's going to give me 2x is equal to -1. Finally, divide by 2 and you get -1/2, or -half. So yeah, that's that problem right there. A little bit difficult, but it's all a matter of understanding the bases, that we have to have the same base. As soon as you can do that, that problem becomes a lot easier to do. All right, let's go ahead and do number 12. Okay. Try to stop the video and see if you can do this one on your own. That's the best way you can learn. Then I'm going to show you how to do it. Well, first of all, realize what the base is going to be. I have a 5 and I see a 25. So the base in this one must be 5. So we're going to have the same base. So it's going to be 5. And then we have that 3x right there is equal to, and then we want to have a 5 as well in here. Why? Because you want to have the same base. Now 25, to get this right here, first of all you have to realize that 5 squared is 25, but since the 25 is on the bottom and I want to bring it to the top, I need to make this a -2. Okay, because the 25 is on the bottom. Now, so I have -2. That's what this is right here. And then I'm going to multiply that times x minus 1, which is this right here. So as you can see, now that we have the same base, I know that this will equal this right here. So that means that 3x is going to equal -2x minus 1. Let's go ahead and distribute now. I'm going to get -2x plus 2. Let's go ahead and add 2x on both sides so that this and this will cancel. We end up getting 5x is equal to 2. That means that x is equal to 2 over 5. Okay, so make sure you guys write that down in your notes as well. So these problems, they're challenging. That's why you have to practice them quite a bit. All right, we'll do 2 more and then we'll be done with this video. I'll do this ones pretty quick since we have done a couple of this ones already. On this one, I can see, since I have a 25 and a 5, I can see how the base is going to be 5. But 5 to the second is what's going to give me that 25. This looks very similar to the previous round, but it's not. Okay, and then I have 5x plus 6. As you can see, now I have the same base. That means that the exponents must be equal to each other. Of course, 2 times 2 will give me that 4x that I need, and then I have x plus 6. Subtract x on both sides and you will get 3x is equal to 6, which means that x better equal to 2. Okay, so that's another example that you can look at as a reference when you're doing the homework. Let's go ahead and do number 14 now. And here you want to have the same base. Look, you have 4 and you have 16. So we can keep the 4 the same way like that. Some people will change it to a 2, but not on this one because I know that 4 to the second is 16. So as you can see, we have the same base now. That means that this will be equivalent to this right here. So now I have 2x plus 5. That better equal, well, let me actually distribute as I write this down. We have 2x there, And then 2 times 1 will be 2. When I subtract 2 on both sides, or 2x on both sides, what's going to happen in here is something that has happened before, and you have seen this before. This and this cancels out, and you end up getting 5 is equal to 2. Now you're wondering, is 5 actually equal to 2? Okay, absolutely not. Okay, so this, since 5 is not equal to 2, this problem actually has no solution. Because when we were solving this, we couldn't actually find a solution to this. As simple as that, guys. So there will be problems, when you're working on this, there will be problems where there is absolutely no solution, which is fine as well. Okay? Alrighty, guys, so that's it for this video. I hope you guys learned something today. If you didn't, go ahead and rewatch the video. That's the great thing about this distance learning, that you can just rewatch the video in case you didn't understand something. Alright, I'll see you guys on the next video.